Hi everyone. You're looking at a box that I had built when I was working with Thane, testing out his coils with the spinning of the magnets and all that. And what you're seeing right now is that Ryobi motor, which is a very high-speed induction motor. I think it's like a 6,000 RPM. No, wait a minute, sorry. No, 3,000 RPM motor. I've got it going through my variac though at this time, so it's kind of dialed down compared to the full speed. It might be at about 1200, 1500 RPM at this time. And what I'm doing right now is I'm just gonna be putting this coil here, which is a inductor out of a primary of a microwave oven transformer. So this stuff is the real thick wire, and the idea here is putting this to the magnets coreless, but with the magnets passing on the side. The classical generator, the magnets go by this way, the coil, this direction. And what I'm testing here is with the coil with the magnets going this direction. And apparently there would be maybe a benefit doing that. And what I'll do right now is, while this is spinning, I'm going to insert the coil here. I've got my probe of my oscilloscope attached there, and those two black and white wires are attached to a 50 or 60 microfarad motor run capacitor, so that's an AC capacitor, and I have my voltage meter hooked up there as well on AC setting, and I'll show you. And as well, we have a 10 ohm resistor right there, so 5% RFIT 10 ohm resistor. And if this does really work out and it's not creating drag other than the eddy currents of the copper in the magnets. Oh yeah, by the way, that's a 10-inch Lexan rotor, and it has 1-inch round, 8 1-inch round neo magnets embedded, but these magnets are only 1/8 of an inch thick, so they're very thin magnets. So it's not very powerful. They're only N42s, 1/8 thick by 1 inch in diameter, and there's 8 of those. And when I put the coil on it there, I can get up to about, I'm doing two things at the same time here, about 2.5 volts at its max there on that 10 ohm load. So that's pretty good power considering those magnets. And if I put the coil in the traditional way, this way here, I get a little higher, but I think that's maybe because the magnets are going there and also there. When I have it here, it's only hitting one side here, so maybe that's why the voltage may be slightly less. Anyways, be interesting to look at this. And here's my scope probe there across it, and that's the wave that we were getting with the scope probe. And let's see here if we can get the frequency data there. So I'll pause the camera and I'll detach the load, and then we can look at it without the load. Okay, I took the alligator clips off that were going to the load there, so we just have the scope probe on it. And what I want to show you is when it's not under load, this is what the scope shot looks like here. So it's a different waveform. There's the magnet, there's the coil away from it, and this is when I approach it. And there is the data. So when it's seeing it this way, it's seeing a higher frequency because of the extra bumps there. I'm all doing this with one hand here, so it's a bit shaky and on an angle. So anyways, I'll post that video, and hopefully that can help with the looking at the possibility of having a generator with the magnets going sideways here of the coil instead of going this direction of the coil, and seeing if there's a benefit with that. Thanks for watching. Bye.